Hello and welcome. In this video, we're going to be discussing how to solve rational equations like the one you see on your screen. So my first step in solving rational equations like this is to clear out the fractions without changing the balance of the equation. So our first step in doing that is to find the least common denominator. So our least common denominator has to be a multiple of each of the denominators. So that means if we look at our denominators, we've got v plus 5, we've got 3, and we've got technically 1 for this last term. So that means our least common denominator has to have a factor of v plus 5, a factor of 3, and then technically a factor of 1 in it. So that means the least common denominator would be 3 times v plus 5, and then times 1 isn't going to change anything. Okay, so once we've found that least common denominator, what I'm going to do is distribute that least common denominator all the way through both sides of my equation. So when I distribute, I start by just putting all of my original terms in parentheses. So I've got my first term, my second term, and my third term. And then I'm just going to write 3 times v plus 5 over 1 in front of each term because I'm distributing that through. So I've got 3 times v plus 5 over 1 in front of the first term, 3 times v plus 5 over 1 in front of the second term. And then for the third term, since it's not a fraction, I'm just going to write 3 times v plus 5 in front of it. Okay, the second step then is let's clear out what we can. So notice if we look at the first term, I've got a v plus 5 factor on the bottom and a v plus 5 factor on the top. That means I can divide top and bottom by v plus 5. And then all I'm left with is 3 times 1, which is 3, times 4, which is 12, over 1, which is just 12 still. If we look at the second term, we'll notice I have a 3 factor on top and a 3 factor on the bottom. So if I divide top and bottom by 3, that will leave me with a 1 there, a 1 there. And so what I'll be left with is minus. And then I'll have a 2 and a v plus 5. And the bottom really just becomes 1 again, so I don't need to write it. And then on the other side, I've got 3 times v plus 5 times 3. Well, what I'm going to do is just rewrite this side so that the 3's are next to each other. And then the v plus 5 is in the back. I can do that because multiplication is commutative. It means I can switch my terms around. Okay, now if we just clean this up a little bit, 3 times 3 is 9. And then on the other side, let's distribute that 2 through. And really it's a negative 2. So negative 2 times v is negative 2v. Negative 2 times 5 is minus 10. Okay, and on the other side, let's distribute the 9 through. So 9 times v is 9v. 9 times 5 is 45. So on the left-hand side, notice I do have a couple like terms that I can combine there. So 12 minus 10 is 2. Minus 2v equals 9v plus 45. So now all I want to do, once those fractions are cleared, is I just want to solve what's left. So let's get all of our v terms on one side. So I can either get rid of all the v terms on this side, or I can get rid of all the v terms on this side. I personally like working with positive numbers, so I'm going to get rid of these guys. And the way I'm going to do that is just by adding 2v. If I add 2v to both sides, I'll be left with 2 equals 11v plus 45. And then let's get the 45 to eliminate that from the side. So we'll subtract 45 from both sides. If we do that, we'll be left with negative 43 on this side. On the other side, we'll have 11v. And then the last step is let's divide both sides by 11. And our final answer is going to be v equals negative 43 over 11. Now, I'm not boxing it in yet because it's not really, I shouldn't say it's really an answer yet. It's a candidate answer. So one of the things we always need to be careful of when we solve these rational equations, rational just means we've got this variable part in the bottom here, I have to be careful that my solution is valid. And what I mean by that is, and you'll notice that on the bottom here, I've got v plus 5. Well, if I plugged my answer in and I ended up with a 0 on the bottom, I would have to throw my answer out. I'd have to throw my solution out and call it extraneous, because I would end up with 4 divided by 0 in that case. And that's not defined. So what I need to make sure of is that when I have my answer, my solution, that when I plug it in, I don't end up with a 0 in the denominator position. So if we take our solution, which was negative 43 over 11, and plug it in, so all I've done is I've taken our original equation and just rewritten it with our candidate solution below. So what I want to do is take that negative 43 over 11 and plug it in for v, and let's just see if we end up with a 0 on the bottom. So 4 over negative 43 over 11 plus 5 minus 2/3 equals 3. Again, all I'm really concerned with here, I mean, I certainly could check to see if my solution works, but what I'm most concerned with is that this guy isn't 0. Well, I can be pretty sure at this point, even though I haven't calculated what this is. Negative 43 over 11, well, it's pretty close to negative 4, and I know that that plus 5 is definitely not going to equal 0. And so I know that my solution, at least in that regard, is okay. So it's not what we call extraneous. If I wanted to be totally sure that all of my steps were correct, I could actually simplify this, and what I get on the left-hand side should equal what I get on the right. But again, all I'm most concerned with at this point is that I don't have an extraneous solution. So negative 43 over 11 plus 5, again, I have no idea what that is, but I know it's not 0, which is what I was concerned about. Okay, so here's another problem for you to try. Pause the video and then restart it after you've given it a shot. Okay, so our first step, again, just like before, is to find that least common denominator. And in this case, because we only have one denominator, our least common denominator is just going to be y minus 3. So then what we're going to do, just like before, is we're going to distribute that y minus 3 to both sides of our equation. So I'm just going to put both terms in parentheses, and then I'm just going to put this y minus 3 in front. And then over here, since I have a fraction, I'm going to write that as y minus 3 over 1. And now let's just clean this up a little bit. So on the left-hand side, I've got 5 times y minus 3. That means I can distribute that 5 through. So I'll get 5y minus 15. On the right-hand side, I've got a y minus 3 on top and a y minus 3 on the bottom. So I can divide top and bottom by y minus 3, and that just gives me a 1 and a 1. So if I multiply what's left, 1 times negative 2 is negative 2. Over 1 is still negative 2. And now I'm just going to solve what's left. So let's start by adding 15. So I get 5y equals 13. Divide by 5, and I get a candidate solution of y equals 13 over 5. So if I take that 13 over 5 and I plug it in here, well, again, 13 over 5, I don't know what it is, but I know that number minus 3 is definitely not 0, because the only number minus 3 that equals 0 is 3 minus 3. So 13 over 5 is definitely not equal to 3, so I know that my solution is okay.